Yep. Before I introduce, how we can make a DNA and navigation and many things, I'm going to introduce a couple of things because some of the things I'm going to introduce is very important. So if you understand that, the whole work process for B will be very easy. Okay. So first thing is, you guys remember that some resemble things? Yep. I think you guys already checked the resemble, yep. So resemble, what it does, if you press the F1 key for help, it shows you what is a resemble is, basic description about that particular node. But sometimes it's really hard to use with the things, right? So I'm going to show you some kind of very useful things with resemble things. Okay. So let's create another counter. Yep, counter. Yeah, counter. And then let's create another bang. Okay, bang. And create another integer IO box with the left mouse click, or right mouse click, and then connecting to maximum. Okay. So change maximum to the 5. And if you make another output IO box from output or from the out pin from the counter, by press the middle mouse, just drag, press this pin and drag your mouse, and then press the middle mouse. Then the B automatically create some kind of IO box. Okay. Good. Yep. So if you press the button, it will automatically, increase number, right? That is, the pointer. So what I want to do with this resemble is, if you create this one, if you're connecting this maximum number to the resemble and change mode of the resemble to the point, okay, and make another node, the main loop, okay, main loop. So change the maximum foreground FPS to 5 because I want to show you how it works. Okay. All right. Now, what are we gonna do? Another is and create another resemble spread. This time is the same amount like this. Okay, and change into the point. Okay, and then type set slice. So this counter number is linked to the index for the set slice, and we're gonna use this resemble, yep, as the reference for set slice. Yep. Okay, good. So far so good. And then I'm going to create another IO box, integer IO box. This process, just to check for the flow, right? So we need to create some kind of space to checking the data. So click this IO box and bring up the inspector by Control and I. and change count low is 5, and the slice count mode into the page. So you can see that five different number in a row. Yep. Good. Okay. Good. I think it's good. So far so good? So we're going to connecting output from the set slice into this number, okay? Into this I/O box spread. So now, if I click, and change the input value 1, okay? Change input value for the slice 1. So now, if you press this button, this bang, you can see the list being changed, yes? So, for example, this one is index number 3 is become 1, yes? And the index number 4 is become 1, okay? In 4B, 1 and 0 is like on-off switch, okay? So, with this, we can create some kind of very interesting switch. Yeah? But there is two different types of the switch normally. One is bang, the other one is toggle. So, for example, the light switch itself is like a toggle. Okay, we turn on, they keep state on stage, yes? Right? We turn off, they become turn off, right? So bang is more like this. Just the ones doing something, right? So by connecting this kind of things, we can create some kind of toggle switch. But how we can make some kind of bang switch with this? So if you're connecting this one to here, okay, and then if you copy this one and connecting this one to here, right? Okay, and then every time you press this bang, and then look at that this section of the resemble data, if you press the bang, they temporarily switch on, right? Temporary switch on. But what we have to do is, we have the 5 different switch, and we can 5 different switch for toggle, and we need to use the 5 different switch as the bang, right? So, if you're connecting these two values somehow, you can create the bang switch as well. This is actually the toggle switch. I will type here. Yep, toggle switch. And somehow, with this, I'm going to create the bang switch as well. Okay? So, to doing that, we need to type equal end, len end. Okay, end. Okay? Then you need to connect this one to here, and connecting this one to here. All right. So now let's see what kind of behavior actually the end give us. So click the end. If you press the F1 as a help file, you can see the end itself has a very strange logic itself, right? So look at here. Okay. The end itself only give you on state if both sides is 1. Okay? Okay? Even though both sides is the same by the 0, they never give you on state. Yeah? Right? See that? This is 0. This is 0. this is only one key. Yep. So if you connecting these two things, okay, so whenever you press this bang, the whole list of this one is instantly change 1, right? Everything is 1. And this one has, still 1 in here, right? So let's see that. And then if I just copy this one again, and then connecting this one to here, okay? Okay, so now for check that result in visual, let's gonna create toggle list, toggle spread. So change it to call rows and pages, and change it row is 5. So you can have 5 different toggle box here. So if you can connecting this one to here, you can see that the toggle switch is on. Yep. And then if you create another bang with 5, so now I'm going to connect this one here and then move this one to here. So let's see the result. Okay. Yep. So now if I press this one again, look at that, the toggle box and bang list. Yep. Yep. So the reason I introduced this one is in 4V, everything is related to how you can control the event. Okay. So sometimes event itself, you need to give some kind of signal to on and off. So that means you need to create lots of, the switches. Yeah, good. Another things I wanted to show you is so far so good? Understand? Tina, understand it? Yep, good. Okay, good. So so it's good. Okay. So if we apply this kind of structure into like for example, the ball moving. Okay, there is one chord in the screen. Okay, they're moving around. Okay, if they hit something, yep, they need to say yes, and which means that they give signal to the on. Yeah. But if you play or display the 5 different balls, 1, 2, 3, 4, 5 different balls, and if you want to check which ball is actually hitting with that particular location, yeah, then you need a very specific way to extracting the index number, right? Because there's 5, and then if, for example, the 3 is being hit, so you need to get number 3. So that kind of case, okay, so we can if you attach something in here, we can do the result. We can produce the result. So let's type to the multi flip-flop with advanced. Okay, advanced. Okay, advanced. So multi flip-flop has the 2 different types. One is animation. Okay. The other one is animation advanced. We're going to use this one. Because you didn't install that add-on. Did you guys download add-on? No? No? Okay, so if you go to the you have Yeah, okay. So go to the POBI website. There is the add-on, to download add-on, and you need to, okay. Anyway, just if you don't have, just look at here, all right? So I'm going to show you some magical things. Connecting this one in the number, if you are connecting this one to here, and the count, what is the count for, Sylvia? Yep. Count for index number, right? Or slice count. Okay, anyway. So look, if I hit, they'll give you the number. So, yeah. They said, this one said, okay, now third switch is on, fourth switch is on, five switch is on, something like that. Okay? So how we can use this number is, for example, if we use the switch, so switch node, for example, and then if you create, attach this one into, okay, sorry, I'm just doing something. Renderer, EX9 renderer, toggle in, and connecting this one to here, and if you connecting this number to here, okay, I'm gonna create the, okay, just a 2, don't worry. I'm gonna show you that some example things. Okay, put here, and then create the segment. At the moment, it's very, my vvvv is very slow because I'm capturing this whole thing, right? So if you click that, see that, this is 0 and this is 1, right? So just see that 0, 1, 0, 1 is going to be repeat, but this is 0 stage. We can see the code, and if we click again, we can see the grid. Okay, so this kind of, at the moment we use the count, so it's very obvious which number is on, which number is off, right? But sometimes you can use without the counters, all right? So then you can use that things. Understand? Right. Yep. Yes. Yes. Little bit. Little bit. Okay.
What happens if you don't put the count on?
This count on?
You don't have the count.
That's a good question, because normally, yep, I need to show you this one, sorry. Okay, so normally, do you guys remember what is the flip-flop means? Yes, memory state, right? So if anything is switched on, they remember that things, right? So, for example, this one is traditional multi flip-flop. Okay, so for example, if you count number 3, and then I'm gonna create something. I'm gonna explain this one as well. So, okay, I'll put stellum. I'll put 3. Oh, sorry. Let's create it here. And another bang. Okay. Another bang. Okay. Okay, this case is more like the traditional case for the multi-flop. Look at that screen. Yeah. So if you bang here, it's been 0 because the first one is being on, and if you click second one, they give you the numbers which one is being activated. Yeah. The third one is going to be number 2. But the problem with this one is you have to manually keep the size. Okay? So there is no, the pin for determining the size, which pin is going to be. So if you want to create one more pin, you need to go to the inspector and give number 4 like this, yeah? But this one is flip-flop animation advanced, is add-on things. So this number, so this number, set count, is exactly same as this one. So if you change for example, if you want to compare 100 things or 10 things, 10 code is moving around the screen, okay, then you can put number 10 into the set bin size. Then you can check which one is being activated. All right? Yes. Yeah. So that is really important. Okay. Whenever you want to make, sometimes you really want to know which one has the on or which one has the off. So you must remember that multiple of advanced animation advanced, we can use the switch. Okay, so extract that. Okay, don't worry too much about that, but we will have a look at this one as well. Okay, so far so good, I think. Yes. So I introduced the resemble things. Yep. And then slice and end. The end condition and the characteristic of the end node, and also the very important to remember. Okay. So end only give you number 1. Okay. When each pin has the same number 1. Okay? Have to remember that, right? Yes? Good. Good. Now, let's create some. Let's create a DNA first. I like probably you guys like the DNA things. Yeah. Okay, let's create the DNA. All right, we're gonna start from the scratch. Okay. So we're gonna draw the DNA. So we need the renderer. Yep. Renderer. Okay, renderer. And then this time, I'm gonna give you some other things for the groups here. Connect. Okay. So for the DNA things, we need a sphere and we need a cylinder. Yeah. So somehow we need to bring the cylinder node and the sphere node, right? And then what else we need? Transform? Yep, transform. And what else? So we also need, the camera to, things, okay? What else? Spread, circular spread, and the linear spread. Okay, so the sphere, cylinder, and transform, circular spread, just bring that in. Okay, circular spread. Okay, and the linear spread, and transform. But this time we have to use the 3D things, right? So not 2D, transform 3D, okay? And the sphere, for sphere, we're gonna use the sphere geometry, okay, sphere geometry. And cylinder, we're gonna same things, the cylinder geometry. I think, yep, okay. And also we need the camera. So for camera, we're going to use this one, transform soft images. Okay. Okay. Now, a couple of other things I'm going to bring in here. So I wanted to see my mouse, where is my mouse is. Okay, so we're going to use the cursor this time, from now on. Okay, cursor. So you can select the cursor DX9, okay, cursor. And then also, if we wanted to create some kind of 3D shape, it might be useful if there is some kind of, the guideline to indicate, the which direction is with Z direction, which one is X direction, which is the Y direction. Okay, that is called X. That is grid. Axis and grid. Axis and grid. It gives you some kind of the basic information or indication of the 3D space. Okay. Right. Okay. And then let's show these 3D things. Okay. So you can see that they have some kind of the color things, right? So for color things, we need some kind of resemble. Okay. So resemble, just to select the resemble color. Okay, color here. Okay. And then what else? What else we need? What else we need? We have we missed the very important things. Aspect, yes. Good. Aspect you. And what else? Okay, so I think that this is the second time for the the 3D things, right? So in 3D, okay, if you want to draw some object in 3D, it's the same as the Maya and the Max. 3D has some kind of writing, yes, and some kind of information about the textures, things like that, right? So which is called the renderer state. Okay, we need to bring that on. So, and then also there are a couple of, if you go to the list for the nodes, okay, and then going down the render state, geometry, sorry. I can't remember. I can't remember where it is, but okay. So if you Pong render, okay. Effect, okay. So if you check the list for EX9 effect, okay, there are a couple of different renderer. No, it's 3D things for the render 3D object. Okay, so this one, or the ping, the pong, yep. And then where is another one? There's another one. Yep. Oh, yep. The flat point, things like that. So now we're going to use this one, the pong directional. Okay. And then the pong directional effect, we need each object, okay, each object must has each pong directional node. Okay, so if you want to draw the sphere and if you want to draw the cylinder, you need another pong directional things here. Okay? Good. Yep. Okay, so now you need some create, and also if you want to check your mouse point or mouse position, also there is another thing you need to call, which is mouse node for system window. Okay, mouse system window. Okay, now let's do the connecting things. All right. So can you guys create another group things? Yeah. Group text now I'm going to create a 3D space first, then we can dealing with this one, right? Okay. So for 3D space, we're going to use this X and grid as the guide. Yeah. So connecting to the guide group here. And then we're going to create another the toggle switch, and then connecting this toggle switch into the last pin of the input for this group. Okay. Yep. Okay. And then connecting this one to the first pin. Okay. At the moment we can't see anything because the toggle switch is none. Yep. So if you on, we can see something. Yep. So red indicating X, the green indicate yes, and blue indicating Z. You can't see the Z at the moment, yes, but we can see soon. So now we're going to attach the camera, okay, camera. So just across that. Huh?
I don't have a camera.
You don't have camera?
No.
Okay, now we just holding little sec. Okay. Okay, bring to camera in this renderer. You need connecting view from the camera to the view in renderer, and then projection to the projection. Okay? Yep, good. Good. And if you click the camera and press F1 key, you can see some of the description of the camera itself, right? There are keywords for how you can control the camera location, things like that, yep. But I'm not going to use that keyword, all right? I'm going to somehow attach the mouse interaction itself to control the camera view. Okay, just close this one. Okay, close this one. And what we have to do is, now I want to create the cursor in this renderer. So you need connecting this one cursor into this group. Yep, in here. And then you need connecting the mouse node. The first pin is the mouse state. Yep. So you need connecting the mouse state to the first pin of the cursor. So after that, you can see my mouse is move on. Yep. All right. Good. So far so good. Then somehow, and I'm gonna use X and Y mouse location, mouse position to change the view angles of the camera. Okay. So if you're connecting the X with roll, you can see the rotation is going on. Yep. And if you're connecting the Y to the pitch, and then you can see that roll up. Yep. Okay. So far so good. And if you want to make a zoom in, zoom out, yeah, zoom in, zoom out, what do we have to do? We're going to use that, this one, the right mouse for the zoom in, zoom out. Okay? So if you move your mouse around that out pin of the mouse, I think it's the last third is right mouse. So if you, okay, so see that? If you, see? The toggle is on, yep. So we're gonna do something with this. Okay, we're gonna do something with that. Okay. So zoom value need to be connected to distance. Okay, distance. So we're gonna create the map. Map. Just forget about the zoom things because it's a bit complicated. Okay, just forget about the zoom. We do not need the zoom things. Okay. All right. So now we have to draw the section of the DNA. Okay. Forget about that zoom things. Okay. So this DNA structure. Okay, this DNA structure. What we're going to do is, we're going to create this one first. Yeah, we're going to create this one first. Then, after we create a unit, then we're going to rotate that unit. Make sense? Okay? Yes? Yes? Okay. So let's change the group account to 3. Okay. So this pin for the sphere, this pin for cylinder. Okay. Connecting the cylinder here, and connecting the pin here. Okay, pin here. And sphere, yeah, okay, sphere. So now it's a little bit, we need to zoom in, so let's change the value, distance. So now we have, 3D shape in here, right? Okay, so strangely, we can see the inside of the shape, right? So if you have that kind of things, you need to change the render state. If you need to go to the renderer inspector, and then you need to check that depth buffer format with the 16. Okay, depth buffer 16. Yep, now you can see that. Okay, so camera view, link to the view. Yep. Projection, link to the projection. Yep. Okay. And then change the initial distance here. Yep. Smaller. Yep. Okay, good. Yep. All right, radio. Okay. So far so good. Okay, so far so good. Now I'm gonna move this one a little bit away because it's a bit distracted. Okay, I'm gonna move this one way away here. Oops. Okay. So now let's dealing with the cylinder first. Okay. So in order to change the location of the cylinder, you need to connecting this transform into transform value, right? Okay. Okay. Now, so in DNA, okay, if there is a center point, look here, if there is a center point, okay, somehow cylinder need to be the mid. Basically, when you draw the 3D objects in the space, the middle point is center point. So we need a little bit move up. Okay? Okay, we need to change it, or we need to change the position of the pivots. So it was exactly the same things we did in center X, center Y things. Yeah? Okay, now, first of all, we need to change the size of the cylinder, the radius of the cylinder. So first pin of the radius, okay, first pin of the cylinder is indicating the radius. So let's make radius small, like radius small. But if you see that radius 1, radius 2, something like that, so you need to provide the equal number for the radius 1, radius 2, because radius 1 is indicating top, radius 2 is indicating the bottom. Okay? So if you wanted to make it even cylinder, you need to provide the same information for each radius. So let's create that things. Okay, first, just I'm going to disconnecting this sphere because I can't see that. And then I don't need this axis and grid, so we turn off. Okay. So now I have the cylinder. Yep. And then now you can decide how long the length of cylinder. Okay. Now let's change it to. Yeah, it's up to you. Just 2 or 1 or just use the 1. And make very thin the cylinder, something like this. Can you see that? Yeah? Okay. Okay, so, and then if you turn on that axis and grid, you can see that it locates the middle of that space. Yep? Yes? Good. So now, we need to move this cylinder a little bit up or down. It depends on you, okay? But if you change the X location, you can see that is moving in this direction, okay? And if you change the Y, you can see it's go up and go down along with that gray things, yep, gray line. So, the cylinder size is 1, right? So if you wanted to move the cylinder, if you wanted to move the pivot point of the cylinder, of the bottom of the pivot point, you need to provide, or you need to move you do not need to move the. Okay. I just confused with that. Sorry. I just do confuse with this. Yeah, I just changed the offset here. Yeah, there is too many ways we can make the cylinder, okay? Just do not change that location, okay? So we need the pivot point change. So type to the Y. Do you remember that how we can calculate the pivot point? The location of the center Y, how we can move that things. So that is based on the proportion, right? So if you type the 0.5, half. So the middle point of the pivot point is moving top or bottom point of the pivot point. Yeah. Good. Okay, good. So far so good. And now we're gonna connecting the sphere. Okay, sphere. Okay, sphere. So you can change the sphere size by changing the radius. So if you keep the small radius and big radius, it's up to you. Okay. Okay, up to you. I'm gonna make it a little bit smaller. Okay. So same things we can do with transform. We need another transformation 3D here. Okay. Another transformation 3D here. Okay. 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 So now we need to do the same things with x center y. Yeah. So if you change that center y, it's up to you. You can move like this, but more like, we apply that some 1.2. Okay. So now we have the cell like this, yeah? Everybody else? Yes? Okay, good. Good. Now, so far so good? Yes? So we have the unit. Then we need to rotate this unit. So how we can rotate this one with multiple things? I'm going to show you this one. We need connecting 3Ds, this one, somewhere around here, where we can connecting this one to which pin we have to be connecting this one. Which pin? I'm gonna connecting this pin to somewhere around. Yep. So where we can connecting this pin. Okay. Transform. Yep. So you guys remember that when we use the two different, the transform. Yep. The income from transform or from the previous transform is become the reference point for the current transform. Yes? So if I connecting to this one to here, okay, and connecting to this one to here, okay, so I'm going to use this transformation. Okay. First, are you going to use that transformation information first? Then, in certain position of that transformation, I draw my units. Make sense? Yes? Make sense or not? Okay. So just so you know, the follow me. So we connecting to the circular X and circular Y, and we connecting this Y to X. Yeah. Yeah. And then you can see many. If you change that spread number, okay, they draw the many different shape. Yep. It doesn't look like things yet, but they draw the something. Yep. And then if you change the width, of the spread. Yep. So they are in the 3D shape. Okay. So if you change the linear spread size, we can draw something here like this. Yep. Okay. And if we provide, as you can see, this information here. Okay. Yeah, I need, yes. Okay. I need to copy this one too. Okay. Okay. So you can draw something like this. Okay, let's do that again. Okay. So delete the circular things first. Okay, sorry. Delete the circular things. Okay, so I'm gonna explain again. Okay. Now, see, look at this. Okay, we're gonna make it a straight line of the object. So, okay, look here. The first transform, okay, they create a positions. The position, and then they tossing their position to the second transformation as the start point. Okay, if you check this one, this transformation things, okay, we never change any value for the x, y, right? Because we get x, y, z coordination from previous transformation, right? Yes, transform. Make sense? Okay, good. Only what we did for this one, this unit, we just change the pivot point of the object, right? Yes. So we didn't provide any information about the rotation. We didn't provide any information about the scale. We didn't provide any information of the XY in this one, right? The XY information, XYZ position, and the rotation, it will come from here. Okay? Yes? Is it clear? So, now, for example, if you create the 17 or 10, okay, 10 linear spread value tossing in here, right? Yep. But here, they create 10 different positions for x, y, z. You maybe wonder why, because we didn't provide anything in here, right? But how come we only provide x 10 times and then become 3D coordination for the, the 10 location, right? Yeah. But when we explain the, the spread normally follow the maximum amount of spread. Yes? Sylvia, do you remember that? Yeah? So, even though there is, just only one spread here, right? Whenever you provide multiple spread here, the end of result will be that maximum number. So if there is no value, zero value, they will repeat that zero value, zero value, zero value, zero value again. Okay? So in our DNA case, we do not need to change XY coordination, right? We only need to change the Z coordination, and we only need to change the rotation of that each unit, right? Make sense? Yes. Yes. Okay. So now we need to provide another information for the rotation. Okay. So if you're connecting this spread count here, and then if you provide this one is, I think you need to connecting this one to the row. Yep. Now you can see that's the DNA structure. Yep. So if you increase number, they automatically create, some kind of spiral things. Okay, because the rotation is starting from 0 to 1, right? Starting from 0 and to 2, right? 1, right? So in linear spread, okay, if the width is 1, okay, linear spread is divided equally, yeah, from 0 to 1, right? So that's why we have the spiral things. Yep. Yes, yes. Color box. 4 low, okay. 4, and if you change this one to things, okay, this is gonna be the color. Okay, you can change the color with right mouse click the right mouse and move your mouse, and then you can change the color. Yep. Okay, good. Okay, and connecting this one, this color, to the color resemble. Okay, and then connecting this value, this 18, yep, to the size of the resemble count. Okay. So far so good. Yes. Okay. Yes. After that, if you're connecting this one to sphere, okay, diffusion color, for example, okay, diffusion color. Yep, diffusion color. Okay, so connecting this number 18 to count for resemble. Count for the resemble here, Tina? There? Okay, good. Okay, so now what we're going to do is create the enumeration, and they're connecting the enumeration to the mode. Okay, mode. Yep. So like that. Yeah. So if you change it to point, they will repeat that color. You can see that. Yep. You can see the difference. And if you change it to the linear, they will change a little bit difference, and cosine. Yeah, just try that. They will create the very difference. That they create very different pattern of the resemblance of the color. Yep. Okay. Because I think you're not connecting that number today. This is because of the okay. So if you turn off that grid, okay, and then change it, click the renderer, okay, click the renderer, and then full screen, change the full screen anti-aliasing to the maximum, yep, and then changing the full screen depth format into D16, okay. Yes, so I think it's fourth one, yep. And then if you click the enter, yep, somehow I can't show you, but you will see the very nice, things. Yep. Okay. I told you this one needs to be changed to 16. Yep. Okay. And then. So you need to, look at the things again and then delete it. Anyway, okay, anyway. If you press that, see? Very nice 3D thing, yeah? Good. So now you like that the 4B, okay? What about Sylvia? It's okay? Yeah, thank you. Okay, don't worry. Enter. Alt enter. Okay? Good. Okay, Tina, you need double check that one because you missed this one. You missed this group, this node.
Yeah.
Okay, and then you also miss that thing as well. Okay. So now, that is all about how we can create a DNA. Okay, that is very simple, but I think it's very useful for SJ. If SJ wants to create some kind of spiral, yes, it might be very useful. Yep. I'm gonna show you quickly after the break and how we can make some interaction. Okay, for example, there is some kind of node which is called the pick. So when you move your mouse, and they automatically pick the 3D object in the 3D space. Okay, that is very useful for the interaction, right? So, but yeah, after 5-minute break, I can show you that. Okay.